Okay, so today we are talking about sequences and series. We'll start out with sequences. A sequence is a discrete function. So instead of being a line or a curve, it's individual points. So the domain is consecutive integers, and it's always going to start with 1 unless stated otherwise. Okay, so starts with 1 unless stated otherwise. So my domain is 1, 2, 3, 4, 5, etc. up until whatever your last number is. And then the output or the range is, we just denote as a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and so on unto a sub n. Okay? So basically my y values are the terms of the sequence. So we can have a finite sequence or an infinite sequence. If it's finite, that means it's fixed in length, right? It has a beginning and an end. So 2, 4, 6, 8, that is a finite sequence. If it's infinite, what do you suppose I put on the end of it? Dot, 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 also known as an ellipsis. Okay, so yeah, just add the ellipsis on the end to show that it's infinite. And there's two different notations that might be used. They may use a sub n or they might use f of n. So you might see it either way, a sub n equals 2n or f of n equals 2n. That would be the rule for those two sequences, right? Because what was I doing, basically? Just taking 1, 2, 3, 4 and multiplying it by 2. All right, so we're going to take a look at an example where we're going to write the first 6 terms of a sub n equals 2n plus 5. So we'll do that one first. So to write the first 6 terms, what 6 numbers am I going to plug in? 1, 2, 3, 4, 5, 6. Yeah, that's all it is. So a sub 1 is just going to be 2 times 1 plus 5, which is 7. A sub 2 is just going to be 2 times 2 plus 5, which is 9. And so on until you guys get up to 6. Okay, so what would a sub 4 be? What would a sub 4 come out to? 13, right? And what about a sub 5? 15. And a sub 6? 17. So did some of you start to notice a pattern? What's the pattern on it? It's just going up by 2, right? Every time, and so on. Okay. All right, then part B, we've got f of n equals negative 3 to the n minus 1 power. So I'll have you guys figure that one out on whiteboards. All right, so you should have gotten 1, negative 3, 9, negative 27, 8, negative 243. So what's happening on this one? What's the pattern? We're multiplying them all times negative 3, yeah. Okay. All right. So if you have to graph a sequence, it's not hard. What you have to realize is what was given to you was just the y values. And so you just have to remember, oh yeah, it starts, you know, the domain is just 1, 2, 3, 4, 5, 6, 7, etc. So 1, 2, 3, 4, 5, 6. Since there's 6 of them, 1, 4, 9, 16, 25, 36. And then it's just a matter of plotting the points. And they are discrete points because the domain is limited to the counting numbers. So it's not going to be a point or a curve or anything like that. All right, so I'm going to scale my y-axis so I can fit it all on there. I skipped one of my multiples of 4, didn't I? 4, 8, 12, 16, 20, 24, 28, 32. Oh. Oh, I don't know why I thought I did. Okay. All right. And so then it's just a matter of plotting the points. So I'm not going to scale the other one. I'll just leave it straight. Okay. So the first point is 1, 1, which would be here. Next point is 2, 4. 3, 9, 4, 16, 5, 25. So you literally are just plotting points. That's all there is to it. Okay? Just don't draw a line or a curve. Okay, we're just going to leave them as discrete points. Okay? Any questions on that? All right, so let's take a look at this one. You are going to have some problems like this on your homework where they don't give you the whole sequence. They just leave you the dot, dot, dot in the middle and then go to 24. So when you're figuring out how high you have to count on the x column, what would make sense to do before you fill in your x's? Fill in all the y's, yeah. So fill in all the blanks on the y side, and then fill in the x's. So we'd have 3, 6, 9, 12, 15, 18, 21, 24. So 1, 2, 3, 4, 5, 6, 7, 8. So why don't you guys go ahead and graph that on your whiteboards. All right, so is that what you guys all ended up with? Yeah, so this one actually was linear, right? Yeah. But we're still not going to draw a line through it because it's a discrete function, okay? All right. All right, so a series is when I add the terms of the sequence together. Oops, forgot the H. Okay, so instead of listing them as separately as 2, 4, 6, 8, I just put plus signs between them. 2 plus 4 plus 6 plus 8. And it can be finite or infinite. Just like our sequences can. Okay, so the summation notation is kind of scary looking, but it's really not as bad as it looks. It's just a way of writing it without having to write everything out. So this symbol is a capital S in Greek, sigma. So we saw a small sigma before, a lowercase sigma when we were doing standard deviation. This is a capital or uppercase sigma, and it just means we're taking the sum, S for sum, right? So on the bottom of the sigma tells us where we're going to start. And then the top tells us where we're going to end. Okay? So that's your domain. Your domain's going to start at 1 and end at 4, and we just count up. We're doing counting numbers, 1, 2, 3, 4. So this would equal 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. And then you just figure out what it is. So 2, 4, 6, 8, and if I evaluate the sum, it comes out to 20. Okay, so is this finite or infinite?
Finite.
It's finite. It has an ending. Okay, but if we look at our next one, we're starting at 1. But does it end? No, it's going to infinity, okay? So you would just write that one, 2 plus 4 plus 6 plus 8 plus dot, 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 dot. Okay, so you can't ever actually come up with a sum for this particular infinite series. So for example 4, I'm finding the sum of this expression, 3 plus k squared, as k goes from 4 to 8. So 4, 5, 6, 7, 8. So I'm going to do 3 plus 4 squared plus 3 plus 5 squared plus 3 plus 6 squared plus 3 plus 7 squared plus 3 plus 8 squared. And then just figure out what it equals. So 4 squared is 16 plus 3 is 19. 5 squared is 25 plus 3 is 28. 6 squared is 36 plus 3 is 39. 7 squared is 49 plus 3 is 52. And then 8 squared is 64 plus 3 is 67. So add those all up. See what you get. Oh, somebody's already ahead of me. Yes, it comes up to 205. So that would be the sum of that series. Well, on your homework, I want you to write out, first of all, I want you to have the problem written down on your homework. And I want to at least see this part. I get that you can probably do that first step in your head, but I want to see the individual terms of the series and then see your sum. Because, again, if you make a mistake somewhere along the line punching it in your calculator, I won't know if you made a mistake just because you hit the wrong key, or if you made a mistake because there was a misunderstanding about what you were supposed to be doing. So I want you guys to show work. I want to see what the original problem is. I want to see the series before you add it up and then with it added, okay? All right, so here's one for you guys to do on your whiteboards. I want you to find the sum as k goes from 3 to 5. For the expression 3k squared minus 7. So again, on your whiteboards too, show me the 3 numbers you're adding together. Don't just give me the answer, okay? All right, so you should have gotten 129, 20 plus 41 plus 68, and it looked like you guys were all getting that answer. Are there any questions on what we covered today? Easy peasy, lemon squeezy, right? All right, that's it for today.
Wait,